this was a derivation that you were supposed to get done in class, and I don't know that everybody did it, so what I'm going to do is kind of go through it now and make sure that you have this in your notes. So let's be very clear. What you're going to be doing is, in this derivation, suppose I give you a speed and an angle. So here's a kind of problem that I would give you is, I would give you, say, theta equals 30 degrees, and this is 5 meters per second, and I would tell you, get me the height, and the range, and the hang time. And first, let's just get some letters with that. So height means the y value, range means the x final, and hang time means the total time it spends in the air. So in other words, I launch this thing, it goes in the air, and I want to know how far it goes in the horizontal direction, how high it goes vertically, and the total time it spends in the air. Now, you could go through and calculate this using the equations, but what I want to do is something better than that. I want us to come up with a general formula in terms of V naught and theta that tells me how to get the height for any speed and angle, and the range for any speed and angle, and same with the hang time. So again, we're going to approach this problem by doing it in two ways, or splitting it into two problems. We're going to do the x direction and the y direction. And what I'm going to do is I'm going to do something here, which is I'm going to rewrite these letters. V naught and theta are things that are going to be given to us, so I'm going to write those in red. So these are things that I will actually be given numbers for to plug into my calculator. And anything that I directly calculate from these, I'm also going to write in red so that I know that it's something that I can directly put in the calculator. Anything that I don't know, for example, this height here, or this range, or again, my hang time, my total time in the air, I'm going to write that in black because I don't know how to get it directly. I have to do some work around that. So, just using SOHCAHTOA and trig, V naught in the x direction. So I had this vector V naught angle theta. Now the thing is, a lot of you in class, I saw you do this, you'd say, oh, r cos theta, r sine theta. Well, that's great if you're splitting up a triangle, but I'm splitting up a velocity, which I can represent with a triangle, but I'm splitting up a speed, so I'm going to write things using speed letters, V naught x, V naught y. So that means this is going to be written as V naught cosine theta, and V naught sine theta. And yes, I expect you to have it memorized that quickly that x is cosine and y is sine. Now the acceleration in the x direction is 0. And now moving on here, the reason it's 0, nothing's going on in the x. So that's how we decided, nothing in the x. All the acceleration is gravity. And that's in the y. So acceleration in the y direction is negative g. Notice I did not write 9.8. So don't write 9.8 meters per second squared, because when you get to college, they're actually going to change this so that you'll solve a problem on Earth, and then they'll say, hey, solve it on the moon, where acceleration is 1.6 meters per second squared. And if you're being clever and using things like programmable calculators, it's going to mess you up if you use numbers, because you want to leave g as a variable that you can input 9.8 for later. Now, once again, my goal is to write down kinematics formulas and solve for unknowns. I'm writing knowns in reds, unknowns is black. So y, my height, is an unknown. T, my hang time, is an unknown. What are all the knowns? Well, let's see. The acceleration in the y direction, that's negative g. Now, recalling from the previous page, if you flip back, v naught y, that's this. I split that into components, so v naught sine theta. Now, v at the top of a trajectory, this is at the top, that's going to end up being 0. And y naught, my initial position, that is also 0, because we're at the bottom. So now, I've got these three equations here. I've got an equation here, here, and here. The problem is these are all for the x. They don't apply to this problem. So what I want to do is, where I see an x here, I want to replace that with a y. And this a here, I'm going to replace that with a negative g. And this v naught, well, no, because now I'm dealing with the vertical direction. That's actually v naught sine theta. And so what I'm going to do is I'm going to take these three equations, and I'm going to actually replace the variables with all this stuff up here. So I'm going to rewrite those equations, and you're going to have your sheet open in front of you and watch what I do, and do it with the correct colors the way I do it here. Okay, so with the y equation, I'm going to have y equals, now 1/2 is something I can put into my calculator, so I'm going to leave that as red. I know what that is. Negative g times t squared plus, now here, don't just write v naught y, write it as v naught sine theta times t plus y naught, which is 0. And then for Vy, again, Vy at the top is 0 equals negative g times t. Said that a little bit backwards than I wrote it, that's fine. Plus my v naught y, which is going to be v naught sine theta. And then the equation for Vy squared, that's going to be 0 squared equals v naught sine theta, quantity squared, plus 2 times negative g times, I'm going to actually open this up, y minus my unknown 0. So let's look at this. In this equation, I've actually got 2 unknowns. Here I've got 1 and 1 unknown. So I'm going to use these to isolate to get hang time and height. So for number 7, it says use that and 6 and 7 and the equations to isolate y. Here's what I mean. I'm going to use this equation right here. So let me write it out. I'm going to get 0 squared equals v naught squared sine squared theta. I'm expecting you to remember a little bit of trig there, that's how you write it squared. Plus 2 times negative g times y. Now I isolate y, and I will actually get my height as, when I actually get my height in terms of red letters alone, will actually be v naught squared sine squared theta over 2g with all the negatives canceling. So this is my formula for height. Whoops. So v naught squared sine squared theta over 2g. This formula here, let me be very clear on this. You will need to memorize it. Okay? I have said it a week before your exam. Get it memorized. All right. Now for the next one. I'm going to use this time formula for number 8. So when I do that, I'm going to actually get 0 equals negative g t plus v naught sine theta, all written here. Now when I solve for this, this will get me the time it takes to go up. So t equals v naught sine theta, all divided by g. But this is half the time. So what I need to do is double it. So when I actually get my full time, my total hang time is going to be 2 v naught sine theta divided by g. Because this time here is just going up. And this time here is going up and going down. So that's that. Once again, this formula here, let me put a little bracket around it. Memorize it as well. So you got 2 formulas to memorize, at least. There's actually a third one, which we're going to do next. So now, in the x direction, the x equation from the buggy lab is going to be v naught xt plus x naught. And let's plug in numbers. So x naught is going to be 0. X is an unknown. And v naught x is going to end up being v naught cos theta. And of course t, well now here we're going to substitute the value from the previous part in red. So we're spending this time traveling, so that means this is going to be 2 v naught sine theta divided by g. So now let's actually substitute. So x equals, and you know what, I should have been more careful about this. This here should be a black t because we don't know what it is. So x equals, here we go, v naught in the x direction, v naught cos theta times t, which is 2 v naught sine theta over g, plus 0. So here's the deal. So again, this is v naught x, and this is t. When we simplify, there's a couple of options here. It's gonna end up being, when you write this out, it's gonna end up being 2 v naught squared sine theta cosine theta over g. This is one way you can memorize this. Now, I'm going to do some trig. It turns out that when I have 2 times sine theta times cosine theta, for those of you that know trig, this is actually a double angle formula. And so another way to write this is, you could either say that the range is this, or you can say it is v naught squared times sine of 2 theta all divided by g. Either of these is fine. Memorize one of them. So you're going to actually memorize these formulas for the exam. So what this means is you have 2 ways now that you're going to be doing problems. Okay, and let me just kind of summarize those right now. See if I have time. I do have time. So let me just kind of make sure we get this. So summary of how we'll solve projectile motion problems. Okay, so this is a summary of how we're going to solve these projectile motion problems. So the first way is you will do equation in the y equals 1/2 gt squared plus v naught yt plus y naught. And then you'll use y squared equals v naught y squared plus 2gy minus y naught. And vy equals negative gt plus y naught in the y direction. And in the x direction, you'll have x equals v naught xt plus x naught. And you will memorize all 4 of these. So yes, do not have any illusions. Memorize. The other possibility is we can use the range and height formulas. So this is one kind of big approach, this here. The second approach is you will use the following formulas. You will use the height y equals, and when I go back here, even I've got to memorize them. So it's going to be v naught squared sine squared theta over 2g. The x formula ends up being v naught squared sine of 2 theta over g. Let me just make sure I got that right. Alright, so v naught squared sine of 2 theta over g. And the hang time ends up being 2 v naught sine theta. See, 2 v naught sine theta over g. Let me make sure I got that right. Yes, I did. So here's the deal. These 3 formulas you will also memorize. So we have 2 completely different approaches to projectile motion. You're going to use both. You're going to practice those for 2 days next week. I'm actually going to give you a homework problem in the next video where you can actually do these problems. So you're going to do this, and this is going to get you set up for practice for next week.